Hopefully it doesn't mess anything up. I don't know. Okay. All right, so for tomorrow, first thing you need to know is distance and midpoint formulas. If you do not know the formulas, make a note to self that you want to get those down tonight. All right, so starting with distance formula for part A. Is it not going to let me write on it? Of course it's not going to let me write on it, because why would it? Yep. Sorry guys, I don't know what is going on with this computer today and this notebook file. Come on. How do I do that? That fix it? Maybe? Yay! Okay. We're good. All right, distance formula, finally. There we go. It's our big square root formula. Square root of x minus x. Doesn't matter which x you start with. So you can use the -5 or the 4. I'll just use the -5. -5 minus 4. And then we square. There's addition between our parentheses. 3 minus -6 squared. Now, because I started with the -5 in the first parentheses, I have to start with that 3 in the second parentheses. We always have to use the same point first. But you can flip those around if you want to, the 4 and the 5 and the 6 and the 3. From there, remember that anything inside, underneath my distance formula here should be positive because we're squaring it. So -5 minus 4, I can do that in my head. That's -9, square it, 81. 3 minus -6, also 9, squared, 81. Okay. Then we add them together. Rad 162. And then we reduce the radical if we can. Do you guys know a perfect square that divides evenly into 162? Maybe? Think about how we got that 162.
2 and 81.
Yeah, 81 and 2, which means it reduces to 9 rad 2. And then you want to leave your answer like that. No decimals on your test unless the decimals are exact. Okay, for, bless you, part B, we are doing the midpoint formula. Midpoint formula is where we're essentially averaging our x coordinates, averaging our y coordinates. You are always adding in this formula, okay? So add up my x's, -5 plus 4. Add up my y's, 3 plus -6, and then we simplify. -5 plus 4 gives me -1 over 2. 3 plus -6 is -3 over 2, and I'm just going to leave it like that, but if you wanted to, you could take it a step further, and decimals here would be exact, so that's fine. Okay, so first problem will just be a basic, use the midpoint formula, use the distance formula. Any questions on that one? All right, problem number 2. All right, so this is also a distance problem. So you're going to need to know your formula. It says find the value of x given that the point x8 is 6 units from the point -3, 4. So if you remember, we did problems like this. If you look back at that first quiz we had, 2-1 to 2-3, there was a problem like this. There was also one on the quiz where it was like 2 distances set equal to each other. When you are given that something is so many units from something else, that is a distance. Okay, so if we're thinking about our distance formula again, that looks something like that, right? My distance, my d value is 6, and it is the distance between those 2 points. So I'm going to go ahead and fill those 2 points in underneath my square root. Starting with my x, x minus -3 squared, and then my y, 8 minus 4 squared. Okay. Now we simplify. I'm going to simplify underneath that square root. X minus -3 we know is the same as x plus 3, right? And then what can you do with that x plus 3 squared? Foil it out. Hopefully we can do that in our head, right? So x squared will be my first term. 3x and 3x will be my outside and inside term, so that's 6x. And then 3 and 3 give me 9. So that's it FOILed. 8 minus 4 gives me 4 squared. So there's a plus 16. One thing that's making this messy is the square root. How can I get rid of that square root? Just square both sides. Square it, square it. So on the left, I'm going to have 36. On the right, my square root and my squared are going to cancel. So that just is going to leave me with x squared plus 6x plus 25. Okay. From here, I have a quadratic. How do we solve a quadratic? What do we do? Get it? Equal to 0. So move that 36 over. X squared plus 6x. If I subtract 36, I get negative 11. Is this all right? Okay. Is this going to factor? This is not going to factor. So what do I need to use? Quadratic formula. Okay. All right, quadratic formula. X equals, what's the opposite of b? Negative 6 plus or minus the square root. B squared will be 36 minus 4 times a is 1 times c is negative 11 all over 2a. 2 times 1. Underneath the square root, I have 36 plus 44, so it's going to be an 80 under there. Does the square root of 80 break down? What perfect square divides evenly into 80? 16 is the biggest one. Remember, you want to pick the biggest one so you don't have to reduce more than one. So 16 times 5 is 80. So I can break it down into the square root of 16, which is 4, and then 5 under my radical. And then the last step, everything in that fraction is divisible by 2. So final answer is negative 3 plus and minus 2 rad 5. So there are 2 possible values for x, negative 3 plus 2 rad 5, negative 3 minus 2 rad 5. Okay, so now we have 3 formulas you need to know for tomorrow. Quadratic formula may or may not be used, but I would say actually for every test for the rest of the year, you want to have that in your back pocket, because even if something's factorable, you might get stuck on the factoring and you might want to be able to use it. Okay, so distance formula, midpoint, quadratic formula. Make sure you have all 3 of those down for tomorrow. Questions on number 2? Okay. Number 3, determine if the given points are one of the following: collinear, which means they make a line, or they make a triangle. And if they make a triangle, is it scalene, isosceles, or equilateral? To answer any of those questions, it's the same work. We need to find the distance between every set of points. The distance between A and B, the distance between B and C, and the distance between A and C. And then once we have those answers, we'll be able to compare them, okay? So 3 quick distance formulas: square root, x minus x squared and y minus y squared. Negative 3 minus 3 squared plus 2 minus 4 squared. That gives me negative 6 squared, or 36. 2 minus 4 is negative 2 squared, so 4. So I get square root 40, and yes, that reduces, but I'm just going to leave it there because I'm only going to be comparing it anyway, so no need to reduce here. So that's my final answer. Okay, distance between B and C. 3 minus 1 squared plus 4 minus negative 2 squared. So that would be 2 squared, or 4, plus 6 squared, or 36, equals square root 40. Okay, so that's automatically going to eliminate scaling triangle for sure, right? At least 2 things are the same. Might still be a line. We'll deal with that in a minute. Okay, A and C now, third set. X minus x, negative 3 minus 1 squared, and 2 minus negative 2 squared. Negative 3 minus 1 is 4. Negative 4 squared, so 16. Again, I have a 4 squared, so that's 16. I have square root 32. Okay, so that eliminated. It's definitely not an equilateral triangle. So the question is it a triangle? And if it's a triangle, it's a scalene triangle. If it's not a triangle, they're collinear points. To determine if two things were collinear, if you remember, we said that the two smaller lengths add to the bigger length. Would the square root of 32, which is the smallest one, plus the square root of 40 equal the square root of 40? That's not happening here, right? Okay, so no. So that tells us it's not collinear, okay? If the two smaller lengths add to the larger length, it's a line, okay? If it's not a line, it's a triangle, and based on all the work that we just did, we figured out it is an isosceles triangle. Okay, so just remember, two smaller lengths must add to the bigger length for them to be collinear. Questions on number 3. Okay, number 4. Calculate x and y intercepts. Let's start with x-intercepts. Do you remember how to find an x-intercept? What do we plug in? A while ago.
Zeros for y.
Yep, think about what you know about an x-intercept. All the y coordinates are 0, so we plug 0 in for y. If I plug 0 in for y, any term that has a y in it's just going to disappear. So I'm left with a 3x squared minus 48 equals 0, and then we solve for x. How do I solve for x here? First step. Speak. Go. Add 48. Yep. And then divide by 3. That gives me 16. And then square root. So my answer is plus and minus 4. Don't forget that plus and minus. You've got two answers. And for me on the test tomorrow, you can just leave it like this. If you want to write it as points, 4, 0, negative 4, 0, that's okay too. All right, let's look at a y-intercept now. Just the opposite. If I want to calculate a y-intercept, I make x equal to 0. If x equals 0, that first term is going to disappear. That leaves me with, I'm going to put my terms in order. Y squared will be left. 2y negative 48 equals 0. All right, and we have a quadratic. It's already equal to 0. Great. Is this factorable? Can we find two numbers that multiply to negative 48 and add to 2? Maybe? If not, you got your quadratic formula. What do we think?
Positive 8 and negative 6.
That's it. Positive 8 and negative 6. So my answers are negative 8 and positive 6. That's it for our intercepts. Okay. Questions on number 4? Okay, moving along. Number 5. Number 5, I am going to be super picky on the grading. I'm warning you now. This says test. This is essentially a proof. If you do not show every line of your work, even though, yes, I agree, you can probably do it in your head, you will lose points because you are proving, testing that something has the symmetry, okay? A proof does not involve graphing it in your calculator and looking at the picture. That is a guess. It is not a proof. So we are showing algebraically, this is 3 columns you need to have on your paper. 1 for the x-axis, 1 for the y-axis, and 1 for the origin. Okay. In each of these, we replaced something in the equation. I know this was a while ago we did this. To test for symmetry to the x-axis, we plugged negative y in for all the y's. To test for symmetry to the y-axis, we plugged negative x in for all of our x's. And to test for symmetry to the origin, we did both, negative x and negative y. So let's look at the first one. I'm going to take the y out of my equation. I am replacing it with a negative y. You must put that negative y in parentheses. If you don't put it in parentheses, one of two things can happen. A, I mark off points because you didn't show your work. B, you simplify it incorrectly because you're missing the parentheses. Both are bad, okay? Then we simplify. Any negative to an odd power is what? Negative. So I know that term, the only thing that should change is that term is negative, or it could become positive if it was an even power. It's the only thing that changes from one step to the next, okay? So first row, we show what we're plugging in. Second row, we simplify what we plugged in. And then the third thing we do is we compare it to the original equation. Is that the same as the original equation? Even if I like divided through a -1, would it look like the original equation? Because sometimes we were able to do that. No. So this is enough to say there is not symmetry to the x-axis. That's enough. And then we just do it 2 more times now. Okay, so I'm going to plug -x in for all of my x's. Take the x out, in parentheses, put -x in its place. That's my first step. Second step, simplify. Is -x to the 5th positive or negative? It's negative. Minus -x is positive x. Is that the same as the original equation? Is it? No, even if I like divided through a -1, would it be the same as the original equation? Nope. This one's also a no. Okay. Third one, take the y and the x out and replace both of them. -y to the 3rd equals -x to the 5th minus -x. So this is kind of a combination of what you've already done in those first 2 columns. We know what the left is going to simplify to. We already said that's -y to the 3rd. We know the right is going to simplify to -x to the 5th plus x. Is that the same as the original equation? Yes, because we can do one more thing to it. If I divide by -1 here, which I could do in the other ones too, but here it's helpful because it's going to flip all my signs. It's going to make it a positive y to the 3rd, a positive x to the 5th, and a -x. And you can see now that's the same as the original equation. So that's a yes. So this would be sufficient work. If there's an answer line, you can just write symmetry to the origin only would be the answer. Bless you. Yes? Does not matter. Same thing. Absolutely. Okay. Other questions on this one? Okay. Number 6, find the standard form of a circle that has a center at -3,7 and contains the point 1, 4. All right, here's another formula you need to know. Circle formula is as follows: x minus h squared plus y minus k squared equals r squared. This is really similar to the distance formula. It's actually where this formula comes from. If you guys see like the parentheses squared, it's subtraction with my x's, subtraction with my y's, add them together. We just don't have the square root over it, okay? But if you know your distance formula, hopefully you know your circle formula. Remember, HK is the center and R is the radius. If you can find the center and the radius, you have enough to write a circle equation. We already have the center. Great. We also have a point on the circle, okay? So everybody agree, even if I draw a picture if I need to, that if I have some point on my circle and the center, that's the radius, is the distance between the two. Okay, so we're just using the distance formula again for this problem. We're finding the distance between our point and the center. That's going to give me the radius, and I can fill in my answer. All right, so distance equals, subtract my x's, -3 minus 1 squared, subtract my y's, 7 minus 4 squared. So that's going to be 4 squared, so 16. 3 squared, so 9. Square root of 25, which is 5. And that distance is our radius. Okay, and it's always going to be positive. We don't have to worry about plus or minus on this one because it's a distance. Okay, so now back up to the top, fill in h, k, and r in the equation. X minus h is a -3. So if I write x minus -3, that's the same as what? X plus 3 squared. Then I have y minus, my k value is 7, so just y minus 7 squared equals my radius squared, and 5 squared is our process, but simplify that. What is 5 squared? 25. That's your answer. Questions getting circle. What if the problem gave you 2 points on a diameter? Remember we did ones like that? What would you do? How would you find the center? Go ahead. Midpoint? How? Okay, so then once I found the center, what would you do? Same as what we did in this problem, right? Pick one of the points. So if you have 2 points on the ends, you just have one extra step. You got to find the center using the midpoint formula. But again, we know our midpoint formula, so no big deal. Okay. Number 7, find the center and the radius of this circle. This involves completing the square. If you need to look back in your notes. Okay, so we're going to review the steps to completing the square. Step number 1 is we're going to group our x's together and our y's together. So that looks like x squared minus 12x if I put my x's together. My y's, y squared plus 18y. And then if you have any constant terms, numbers that don't have a variable, you're going to put those on the other side. So negative 7 is going to go on the other side of my equation. Okay. Then we're going to complete the square with our x's and y's, which if you remember when we did this in class, we added a number on. You can call it the magic number if you want. And we're going to have to add those same numbers onto the right side. Do you remember how we found those numbers? What did we do with negative 12 to figure out what I was adding onto those x's to create that perfect square trinomial? Half it, square it. Does that sound familiar? Write it down if it doesn't. Half it, square it. Half it, square it. Okay, and we're going to do it twice. If I take negative 12 and I half it, that's negative 6. Square that, 36. Do it again. 18, half it, square it. Half it, 9, square it, 81. Those same numbers are being added to the other side. Then we factor. What 2 numbers multiply to 36 and add to negative 12?
6 and 6.
Close.
Negative.
Yep, so I could write x minus 6 if I factored it. Or, if you're doing this right, it should always be the same number twice. So we write it as a binomial squared. X minus 6 quantity squared. Okay. Plus, what 2 numbers, or what number in itself, multiply to 81 and add to 18? What multiplies to 81 and adds 18? 9 and 9. So I can write y plus 9, or I can write y plus 9 squared equals, on the other side, what am I going to get if I add all those together? 81 and 36 gives me 117 minus 7. 110. There's a circle. Can you tell me the center of this circle? Close. Always the opposite. If you look at that previous problem, what we put in the equation is opposite what the coordinates were in the center, because the minuses are built into the equation, okay? What's the radius? Radius is? Yep, and I'm just going to leave it like that because that does not reduce. No decimals. Final answer. Questions on 7. Okay, we got 3 more. Find the equation of the line that is parallel to 7x minus 4y equals 5 and goes through the point 6, negative 2. What do you know about parallel lines?
Same slope.
Same slope. So that is the only thing I care about from that equation, is what is the slope. What is the easiest way to find the slope of that equation?
Get y by itself.
Get y by itself. All right, so I'm going to move the 7x over, 5 minus 7x. And then I'm going to divide everything by negative 4. It's not going to be pretty. Just leave your fractions there. So it'll be negative 5/4. If I do negative 7 divided by negative 4, it'll be positive 7/4 x. What is the slope of that line? It's just whatever's in front of your x once the y's alone. 7/4. Okay, that is the only thing I need from that equation. We're trying to write equation of a line. Easiest way to do that is y equals mx plus b. And I know the slope is 7/4. How do I find b? Well, I haven't used this point yet, right? What do I do with it? Plug it in. Yeah, so my x is 6, my y is -2, and that leaves b as the only variable I can solve for. Let's see. 42/4 would reduce to 21/2 if I multiply those together. Which actually, that's an exact one. If you want to write 10.5, that's fine. And then I need to subtract 10.5 to the other side. So -2 minus 10.5 gives me -12.5 for b. Final answer, y equals 7/4 x minus 12.5. If this problem said perpendicular, what would change? What would change? Yeah, if it was perpendicular, this slope would be the opposite reciprocal. What's the opposite reciprocal of 7/4? -4/7. Flip it, change the sign. Okay, so perpendicular, just one extra step if you see that word. Questions on number 8. Okay, 2 more. Number 9, find the equation of the line that just passes through these 2 points. Okay, well, I have 2 points. I really only have one thing I can do. What can I do? With 2 points. Yeah. Times slope. y2 minus y1 over x2 minus x1. There's another formula. If you don't know that one already, make a note to yourself. Know your slope formula. My y's are 4 minus 4. My x's are, again, it doesn't matter what order I subtract these in. Let's say 8 minus -10. That gives me 0/18. 0 divided by anything is what? 0. As soon as you see a 0 in this slope formula, it's one of our special cases. What kind of lines have a slope of 0? You guys remember slope, dude? Horizontal. And what do the equations of horizontal lines look like? They're special. Y equals a number. 4. That's it. What if the 0 was in the denominator of my slope formula? Can I divide by 0? No, so that's undefined, right? Does that mean my line doesn't exist? No, that doesn't make sense, right? If I give you 2 points, you can draw a line. The line always exists. But if the slope is undefined, what does that tell us? Vertical line. And what do the equation of vertical lines look like? X equals a number. And you'll notice that in the points. If the y's don't change, it's a horizontal line. If the x's don't change, it's a vertical line. That's a clue if you don't. So I really even didn't need to do the slope formula here if I noticed that at the beginning. Okay, or that's a way to check it if you get something weird. All right, questions on 9. Okay, last problem today is why you're going to have your graphing calculator tomorrow. You need a graphing calculator for this guy. Let me get mine up here. We're just going to review the steps. If you ask me tomorrow during your test, how do I put this in my calculator? I'm going to tell you I forgot, because I will. I will have a brain blank. I just remembered. All right. Okay, so follow along with me. If you need to make notes on your paper of what buttons you're pushing, do that. We'll make sure all your settings are good. Okay, first thing we're going to do is hit Stat. Then we're going to hit Edit. Then we're going to clear out anything that's in there. So we're going to go up, hit Clear, go back down. Up, hit Clear, go back down. Does everybody have L1 and L2? Nobody's missing it? We're okay? All right, good. Let's put this data in there. So hours of studying is my L1. 1, 2, 3, 5. What else do I have over there? 7, 12, and 15. Okay. My L2 is my grades on a final exam. So 68, sorry. 71, 76, what else do I have? 83, 89, 92, and 100. And then you just want to double check at the bottom here that you have the same amount of values in L1 and L2, which we do, okay? If not, you missed somebody and you want to make sure you type them in. Okay. Everybody okay getting the data in there? Any questions so far? All right, now to get the equation for the line, which is what we need for this problem, we're going to hit stat again. This time, we're going to go over to where it says calculate, and we're going to choose option number 4. You can see it says linear regression, number 4. And then we're just going to keep hitting enter until it spits out something like this. As long as you have an A and a B, you're good. If you have R's, that's fine, but we don't need them for this problem. Okay. The calculator tells us use y equals ax plus b. They use an A instead of an M, but it's an equation of a line, and they're telling you A is the slope and B is the y-intercept. So first part of this problem is find the line. Here's the line. Y equals, and I'm just going to give it 3 decimal places, 2.134x plus 68.997. There's the equation of my line from my calculator. Second and third parts say interpret the slope and interpret the y-intercept. Doesn't mean tell me what the slope is. I know what the slope is. The slope is 2.134. Slope in real life, we talked about, represents something that's increasing or decreasing. It's a positive slope, so it's increasing in this problem. What's increasing in this problem? What's increasing?
Grade.
Yeah. Your grade will increase about 2.134% every hour you study. That's what that's telling us. Think of it like a 2.134 over 1, right? It's a change in my y's. Changes in my y's are the grades in the final, over my change in the x's, which are how many hours I studied. Okay. The y-intercept. The y-intercept is 68.997. Y-intercepts are always when x equals what? And what does x stand for in this problem? So it tells us if I study for 0 hours, that's my grade, will be approximately a 69%. Okay, it's our starting value. Before any studying occurs, that's where your base is. Initial amount. Yes. Question.
Studying 1 hour.
Right, so this is data. So if we were to graph this scatter plot, that's a good question. And this line, it's going to look something like this. Am I lying? Is it hitting every single point? No. It's approximating the correlation between the variables. So, but that's a good thing to notice. Is it close to that value? Yeah. Okay, so that's reasonable. But yeah, it's not going to hit our data perfectly.
After I plug all this stuff in the calculator, what do I hit to get that?
Stat. Go over to the right where it says help. And then number 4. Yep. Okay, so this is what you're going to see on your test tomorrow. Let me show you now in Polaris where you guys have some extra stuff you can look at tonight. Totally optional. In our course, okay, if you go to the folder that says test review in Polaris, you're going to see the problems for today, and I've already actually posted the solutions for what we just went through. The test review problems, that document is the paper you have, okay? So you've got chapter 2 questions and answers and chapter 8 questions and answers from this packet. The other 2 documents are there. It says extra practice problems, okay? So let me open one of those up. Tonight, you're only worried about the chapter 2 ones because that's the only thing that's on your test tomorrow. So chapter 2, extra practice. Every problem we went through today, there are 3 more problems similar to it. I am not promising you guys, this is not Algebra 2, where exactly what I went through today is exactly what you're going to see on your test tomorrow. It might not be a parallel problem, it might be a perpendicular problem. It might not end up being an isosceles triangle, it might end up being collinear. There's other ways that the problems can work out other than what we just talked about exactly with those problems. And those are covered in these extra practice problems. So if you're not confident with all of these ideas and the way that these problems can work out today, you want to look at these. How this document works is just one big thing you can scroll down on. There's a problem, and it's blank, and then when you scroll down is the same problem with the work and answers written out. So it's a way to almost like make yourself a practice test, okay? You could pick like one of each type, you could try it on your own, you could check your answers, and then if you got one of them wrong, you know to practice a couple more like that. Does that make sense? Yes? Okay, so it's up to you how we study, but remember, we're in a college class now. There are no retakes, okay? There's no, if I miss the test, I get a couple more days to make it up sort of thing, okay? When you walk back into school, you take it as soon as you walk back into this class. So you want to make sure tomorrow, when you are walking into this class, because that's the only time you're going to get to do this, you are prepared. So you're going to take the next 24 hours to prepare yourself however you see fit. I will be here before school tomorrow and a little bit after school today. So if you feel like you need to pop in and see me, you can. You guys have teachers in the TLC you can stop with, or Mrs. Caldwell if you feel like that is necessary. You've got those extra resources too. And then Thursday, Friday, we'll just repeat the same process with all those Chapter 8 questions you guys have. Okay? Any questions for me over any of that stuff? Yes. That's a good question. Let's see if there's one in here, shall we? Or if they're all distances. That's 9 units away. That's 13 units away. That's 10 units away. Looks like you're safe. Okay. Other questions? All right, last 5 minutes are yours. I'll do the cell phone lotto. You're just studying tonight, getting ready for first test tomorrow. These are the big leagues. Have some 40% of your grade in here, 50% of your grade. 50% of your grade. Yes. Almost. Okay. What do we got? 8. Oh, somebody won. Number 8.
How many questions is this part?
10 problems. So they're going to be similar to what we did today. They might just work out, differently. So you want to be prepared for all situations. Who's number 8? Okay. There you go. Yeah. Yes.